Artificial intelligence is likely to be either the best or worst thing to happen to humanity. For many years, scientists have tried to define exactly what is artificial intelligence, AI. Not only computer scientists took part in this discussion, but also psychologists, philosophers, social scientists, neurologists, and even science fiction writers. One of the challenges was not only to define what artificial intelligence is, but also to define what intelligence is in itself. To make a long story short, and maybe to give you a surprising spoiler, so far the scientific community did not reach consensus. One of the most influential figures, and maybe even one of the founding fathers of computer science, is Etzger Dijkstra. He claimed that we should not bother with such questions. To quote Dijkstra, "The question of whether a computer can think is no more interesting than the question of whether a submarine can swim." Well, interestingly enough, although there is no consensus, there is a de facto understanding among AI experts in two key topics. The first is a very high-level, abstract and incomplete definition of a goal to imitate intelligent human behavior. But again, what is considered intelligent is still disputable. How can one define a good enough imitation of intelligent human behavior? This will be the time to introduce another founding father of computer science, Alan Mattison Turing. His view on how to spot artificial intelligence became world-renowned and widely accepted. Can you guess what it is? We will get there in a moment. But first, a bit of history. He worked for the UK government in cracking the Nazis' encryption system called Enigma. This had a pivotal contribution to winning the war and saving millions of lives. He later worked on computational biology and artificial intelligence. He was a war hero and a scientific genius, and he was gay. At that time, unbelievably, people thought there was something wrong with being gay. It was illegal in the UK, and he was prosecuted for homosexual acts. Turing had to go through chemical castration or face being sent to jail. He eventually committed suicide at the age of 41. His death is not only a personal tragedy and a tale of great injustice, but it is also a colossal loss to society and science. How would the world have looked like had Alan Turing's sexual orientation was discovered before the war and he had never cracked the Enigma? Anyway, Alan Turing's answer to the question how to spot artificial intelligence is what became known as the Turing test, which he developed in 1950. In his own words, a computer would deserve to be called intelligence if it could deceive a human into believing that it was human. This means that an AI system will pass the Turing test for a specific task if a human will not be able to distinguish between the results of the computer to this task and the ones of a human. Going back, the second key topic or concept where there is a de facto understanding among AI experts is a set of features to differentiate between the various AI applications. For example, a strong AI, in contrast to weak AI, is considered one that imitates human intelligence by imitating the natural mechanisms or processes that humans and animals have. Such systems may be based on a simulation of the brain and could result in experiencing consciousness, make untrivial associations, or maybe even laugh. In contrast, weak AI is less ambitious, as it focuses on imitating human intelligence by any means that will provide the goods. The case of Deep Blue, which I mentioned in the Spotlight session, is an excellent example of weak AI. Deep Blue calculated millions of possible moves and counter-moves in several hierarchies. The AI only pretended to imitate human chess playing, since it's not what we do in our head when we play chess. Or is it? Anyway, it was good enough to wow the world with the notion that artificial intelligence can be better than the best human intelligence in that field. Another example of a feature of artificial intelligence is general AI versus narrow AI. While a system of the latter kind is capable of solving a very hard and maybe complex problem like chess or interpreting medical images or driving, it doesn't do all of them, nor all other intelligent capabilities humans do with one system. An AI that drives a car can and will save lots of lives, but it cannot understand a simple X-ray image. Those AI apps that interpret medical images successfully cannot tell the difference between the sound of a laugh or a cry. The IBM Watson system that Maya mentioned in the Spotlight session infers personalized recommendations based on clinical oncology data from various and heterogeneous kinds. Although probably it does not know how to make a cup of coffee, it's a step towards more general AI. Having said that, IBM just glued together many narrow AI systems under the brand of Watson. It's still not really general AI. I want you to see two stunning demonstrations for somewhat general AI by IBM and Google. These companies are two advanced players in the field of artificial intelligence. The first demonstration is Watson competing against humans in the popular TV trivia show Jeopardy! The second, Google Assistant talking to random humans over the phone and accomplishing tasks such as booking a hair salon appointment and making a restaurant reservation. Sounds frightening? AI professor Pedro Dominguez put it very nicely. People worry that computers will get too smart and take over the world. But the real problem is that people are too stupid and they have already taken over the world. After this demonstration by IBM and Google, join me in learning two beautiful AI algorithms that become more and more prevalent in our everyday lives. One that tries to be generic and one that tries to be strong. We will view and learn them with specific examples from the medical world. So, I hope you enjoy enriching your intelligence about artificial intelligence.